What is going on, guys? In this video, we are going to be talking about database sharding. And database sharding is a very interesting concept to me because it's kind of the fundamental principle that very large scale systems are built on, because it allows systems to scale out horizontally basically as much as they want. So in terms of the agenda for this video, the first thing that I want to tell you about is just what is sharding and kind of why is it important. From there, we're going to talk about the different options that you have in terms of scaling your database. And then I'm going to talk to you about the options in terms of increasing your database's performance. And there's a couple key ones there. The first is kind of scaling up your hardware. The second is adding replicas. And the third is finally sharding. From there, we're going to talk about the pros and cons with sharding, because although it's a very powerful concept and allows you to scale out extremely well, there are a non-negligible amount of cons that come with using this approach. So I'm going to talk about the pros and cons there just so you get a better handle of what you're getting into if you decide to go with sharding. So let's start out by quickly talking about what sharding is as a concept. Like, why is this important and why should you even care? So sharding is really just a optimization technique for achieving horizontal scalability in databases. And it basically revolves around the concept that with large databases, there's multiple options in order to get increased performance. So instead of beefing these databases up, we can essentially split our databases into multiple smaller ones. So this is the concept of sharding. Sometimes you hear the term partitioning in sharding. Sharding is a specific type of partitioning. And in this video, when I say sharding, I'm really going to be talking about horizontal sharding. There's a different approach, which is vertical sharding, which I'm not going to get into this. I think horizontal is much more popular and much more applicable for large-scale problems. So like I said, sharding is just an optimization technique that lets you split up databases into smaller databases, so that now instead of having one big database, you have smaller individual ones, and each of those can have the same kind of hardware setup, so you get better performance and more data storage. So that's essentially what sharding is in a nutshell. Now from there, I just want to quickly go over what are the options if we are facing kind of a problem where, maybe our database is getting too expensive to run because the hardware is a little bit too pricey now. Maybe we are running into the limits in terms of storage on that database, so we have to dump older data, and that's kind of leading up to restricting our use cases because now we can't query by that older data. So let's talk about some of the options of increasing performance on your database. So the first option is I believe to be the most simple, and that's just scaling up your hardware. So scaling up your hardware. And what this option basically entails is just beefing up your database instance. So if you're running on 8 gigabytes of RAM, then double it to 16 or double it again to 32. If you're running a certain processor, increase the type of processor, increase the performance, or pick a better one that's going to give you better performance. Now, the thing with this approach, it may seem easy at face value, but it doesn't actually solve the underlying problem. And secondly, it's very expensive to keep on scaling up and up and up every time you're getting kind of performance problems with your database. There's a concept of diminishing returns with scaling up your hardware. So what that means is that, say for instance, you double the power of your machine, it doesn't scale linearly. So the performance boost that you get out of scaling up your machine using a machine that's double the capacity or double as powerful, you won't necessarily get double the performance boost. What you also need to be aware of is that there is a technical maximum of how much you can scale up a given machine. Like, there's only so big of a machine that we can build that's at least available on the kind of consumer market, unless you're like IBM or something and you're building supercomputers. But from us simpletons that are just kind of guys that are building systems, there's only so powerful of a machine that you can build. So you can see here that the option of scaling up your hardware indefinitely does have some constraints with it. So let's move on to the second option now. So say that you don't want to scale up your hardware, you want to kind of scale it out a little bit. So a very easy approach is to add replicas. So add replicas. And usually these are, actually, I think always these are read replicas. So let me explain to you what the process of adding replicas actually entails. So the basic, before I draw the diagram, the basic idea is that you make copies of your database. You have, instead of just one database that's fielding all the traffic, you have multiple copies of that database, and the copies are also able to field some of the traffic that's coming in. So now instead of your one database getting overburdened with all the read and all the write requests, it's split up across multiple different databases. So let's talk a little bit about what that option looks like. So in adding read replicas, what this process usually entails is that you have one master node, M for master, okay? And this node is going to be the leader in this problem, or it's going to be kind of the orchestrator you can think of. And there's also going to be read replicas, which are essentially just copies of your master node. So you can have multiple read replicas here, right? You can have n number of read replicas. Now, what the process of adding read replicas entails is that your master node is responsible for receiving all write requests, The read replicas, like the name entails, are not allowed to receive write requests. And that's kind of the reason for that I'm going to get to in a moment, but just keep that in the back of your mind. So in this relationship, when a write request comes in, and let me just get a different color here to demonstrate this, the master will accept that write request and it'll propagate the update to that row to the read replicas, right? So write comes in and then there's a propagation that eventually happens. And the key is eventually it happens. Now, this concept of eventual propagation or kind of delayed propagation through asynchronous means introduces a little bit of a problem. And the problem is something that's called eventual consistency. Eventual consistency. And the name kind of describes what the concept means. Like you can see in this example here that there is a delay from when a write request is received and committed to the master node and when the read replicas get updated with that row. So why is this a problem and why should you care? Well, it's a problem because having eventual consistency in a system can result in stale data. And let me just rewind for a second here because I don't think I explained like the role of the read replica, although you can probably imagine what the responsibility is. So in this model, the master is responsible for all the writes. You can set this up so that the master can also receive reads as well, but that's totally up to you. You have eventual propagation into your read replicas, and then your application layer can essentially choose in terms of reading which node that it wants to read off of. So now when a request comes in, you're not necessarily just reading off of one database and putting all the stress on that one database. You have different options now, and you can read off of the read replica. And this is kind of the strength of this option. By adding replicas, you split up the work so that instead of the queries all hitting the same database, it could be hitting n number of databases, which are essentially copies of the master. Now, the big problem, like I said, is eventual consistency. And I want to kind of throw an example at you here just so I can demonstrate what this means. So imagine we have a write event that occurs on your master node. So a write event, W for write, okay? And the master node accepts that request. It commits that write to its database, okay? And in between the time that that data gets propagated to the read replicas, a read event occurs, maybe from a different query, from a different application, and that read event gets directed to your read replicas. So again, this is in between the time that the write is accepted by the master and that data is propagated into the read replicas. So what does that mean? Well, it means that the read is going to get stale information, especially if that write changed some fundamental attribute about your row. So in the context of, financial world where, account balances and bank accounts and stuff, if you have stale data that's coming out of your database and acting upon that, that's an unacceptable failure. You just can't have that. You can't have scenarios where, you think the balance is something, but because of this setup, this technical limitation, you're performing an action on something, even though that action is not reflective of the true value of the data that you are acting upon. So this can introduce some very, very complex problems that are often very difficult to debug because the source of the problem is at the database level. It's not even at the application tier. So this is one of the problems with adding more read replicas. You get these side effects, and these side effects are not very convenient, and they can introduce some really nasty problems. So that's one of the main problems with adding replicas, right? So what is the solution to these two problems, right? There's got to be another way. So let's scroll down now, because now we're going to actually talk about the main idea of the video, and that is finally sharding, right? And the third option is, of course, sharding. So let me just lay that out here. So what is sharding, right? We saw that we introduced some replicas here, and that kind of solved our problem, but not really. So what does sharding actually entail? So it entails splitting up your database into multiple smaller databases, right? So what does this look like in real life? So here we had one master node. Now in the sharding example, we have, let's say, 3 different databases that we're working with now, and they all contain a subset of the information. So instead of all the information sitting on the one node that we had in the previous examples, we separate that information out into 3 smaller databases and allocate different data to each one, okay? So let's draw out what that looks like. So let's say we have 3 different shards. So the first one, let me get a different color here. Let's say we have S1, right, shard 1. Then we have S2 for shard 2, and then S3 for shard 3. Right? And these are now all different database instances, okay? So these all have different master nodes, right? So master node for shard 1, master node for shard 2, and master node for shard 3, right? And so how would you separate your data out now? Well, the fundamental thing with sharding is that you need some kind of key that is predictable. Typically, it's part of every request that comes into your system, so it's always there. And you use this key as an input to a hashing function, and that key kind of tells you which shard the data regarding that key is on. So what does that actually mean? So let's move down a little bit so I can make a little bit more room to kind of demonstrate this example. So sharding, and I want to grab an image here. So by the way, there's a very, very great article that I'm going to link in the description section below of this video that kind of talks about a lot of these concepts in depth. So if you're not satisfied with this, I'm going to put that in the description section below so you can read it afterwards. So this image that I have here is a straight shot from that article. And in this example, they're using the concept of customer IDs, right? Customer IDs, like you can see. And customer ID is a fantastic example of a good predictable key that you can use to partition or shard your data onto different shards, right? So customer ID, it never really changes. It's something that you pick in the beginning. It's predictable, it's not changing. It's something that's globally unique. It's got all the properties of a good key that we want in this example. So what are we seeing in this example here? So we have a concept of horizontal partitions, and that's denoted by the color here. So the tan color or the salmon color is for shard 1. And I know I'm using 3 shards here, but let's run with this example where we're using only 2. And then the second color, the blue color, is the second shard. So all of the data for customers 1 and 2 is located on shard 1. So let's put that over here, 1 and 2. And let me actually just erase. Oops, I'm on a different layer now. What did I do here? Okay, so let's get rid of that. Perfect. Okay, so we have customer ID 1 and 2 that are located on shard 1. And then we have customers 3 and 4 that are located on shard 2. So what we get with this scenario now is that we have our data split up across different databases. Well, the next natural question is, when a query comes in, how do you know which database to look at? How do you know that customer 1 is on shard 1? And how do you know that customer 3 is on shard 2? So this is a fundamental concept with sharding. You need some kind of either master table that's going to contain, this customer's on this shard, this customer's on this shard, et cetera, or you need some kind of predictable hashing function that is crafted in such a way that you can introduce concepts of versioning, because there's some cases where you need to introduce shuffling, so moving customers from one shard to another. So you need to introduce some complexity here if you're going to use the algorithmic approach. But if you're using an approach where you just have a single kind of smaller, simple table that says customer ID 1 is located on shard 1, what are the problems with this? Well, you have a single point of failure. And this is one of the things that sharding is supposed to solve. We saw that in the previous examples, we have one database. If that goes down, your whole application goes down. Now we're saying we need another table, a small, although simple table, that says, customers are on particular shards. What happens if that goes down? Well, your whole system blows up, right? No queries will work. So that's one of the things that you need to be aware of. So if we flesh this example out a little more, and I just want to introduce this second diagram here. Let me make sure it fits on the screen correctly and lines up and everything. This is kind of telling you a little bit about what I was trying to describe, where over here we have S1, right? And you have customer IDs 1 and 2. And then over here you have S2. And this is where customer IDs 3 and 4 are located. So you can quickly see the benefits of this now, right? Like this information that's located here for customers 1 and 2 is on a completely different master node, a completely different database. And all this information is located on another completely isolated database. So, assume the worst. Assume this database goes down. Well, that's a terrible thing, and it's definitely going to impact your customers. But now you have this database that's storing a subset of your information that you can still field traffic and receive and process traffic for customers 3 and 4 in this case, even though your first shard is temporarily down. So this is one of the main pros about using sharding. I'm going to get into this more in the next section where I talk about the pros and cons. So one important concept that I haven't talked about yet is now we have this additional complexity, right? We have this concept of different shards. Your data is split up across different databases now. It's not looking very nice. How do you kind of solve this problem where you need some kind of routing layer or some kind of concept when a request comes in? Instead of hitting the database directly, you need to introduce another intermediary layer that says, query this intermediary layer, and that intermediary layer is going to be responsible for looking up which shard each customer is on and then forwarding the request to the corresponding underlying database instance. So what you may have here, let me just draw this diagram out a little bit, is that you may have a scenario that looks something a little like this. So when request comes in now, these are requests. Instead of like in the simple example, they're just hitting a database directly. You need to have a different layer now that sits between your application tier and your database. It's kind of like an intermediary tier that's handling all the routing logic for your queries. So now when a request comes in, they need to hit this, layer, this routing layer, right? And this routing layer, like it's going to be some kind of, RESTful endpoint or RESTful application or something like that. And it needs to have logic caked into it to say, request comes in for customer ID 1. It needs to know to go and look up the table that contains the shard that the customer ID 1 is located on. And then it needs to know to go to S1 for customer ID 1 and 2 in this example. And it needs to know to go to shard 2 for customer ID 3 and 4 in this example. So you have this, let me get a different color again. You have this dance that goes on this routing layer. And the problem with this is that it's an additional layer of complexity now, right? Like you have this additional thing that you got to build that needs to know how to route this traffic. It needs to be able to handle failure modes. It needs to be able to handle single points of failure now if you're using a database to store your shard locations. So there's a lot of subtle problems that go into this. So this is the fundamental idea of sharding. It's the idea that instead of having all of our data sit on one database instance, we split it up and introduce a routing layer so that we can forward the requests to the right instances that actually contain the data. Now, easier said than done. This isn't just something that you can go and click, right? This is something that you need to build because it's expensive to maintain a system like that. Now, before I get into that, let's just move on to the next section where I talk about the pros and cons, because that's really going to cover all of this stuff. So let's talk about the pros and cons now. Like, when is it worth it to actually do this thing, right? So pros over here, and we want cons in red. Okay, so let's go through each of the different pros and cons. All right, so the first pro is scalability. T. right? We saw that instead of having one database instance and it being kind of the single failure, we can chunk our data into smaller independent databases and just keep on cutting that down and just chunking them over and over and over again. This is actually a recursive problem. If you starting with one shard, you can split that into two, and then if that doesn't meet your needs anymore, you're starting to have performance problems. You split it into 4, and then 8, and then 16, and then 32, and you see it just keeps on going and going and going. And this is how you achieve essentially infinite horizontal scalability, because you can always just chunk your data into a smaller subset of the problem. And by having these additional shards, you're introducing a little bit more complexity, but you're also enabling more scalability. So that's one of the main pros of using this approach. The second one, and it's kind of a two-in-one, is availability and fault tolerance. And I kind of touched on some of these things previously as I was running you through the example, but let's hash this out a little bit more. So availability in the sense that if one database goes down, then you're down for a subset of your customers, and that sucks, right? Like, it's never a good thing, but at least your database now can still field traffic for the remainder of your customers 3 and 4 that were on Shard 2 in the previous example. This is a great thing, because if you're operating a system where you only have one database and that database goes down, your whole application is down and your hands are tied. You can't do anything. Everything stops. You need to go and fix the problem before the business can keep running. So using this approach, your data is split up across all these different nodes now, and the likelihood of them failing all at once is very, very slim, unless there's kind of some bug that you introduced. But like in terms of like a hardware failure or something like that, where it's something where you're out of control or you don't really have a say in that, then you can clearly see the advantages here. So that's it for the pros. Now I want to move on to the cons now. And the cons are kind of a laundry list of things, and not necessarily because using this approach is a bad thing, just because it's an expensive thing to invest in, because you get these great benefits, but they're also come at a cost. So let me actually scroll down because I need to make a little bit of room for this. So the first one is that, well, this is kind of like an umbrella problem, but and actually let me get a different color because I'm going to use color coding here. So the first con is complexity. And this shouldn't be a shock if you've made it this so far in the video. There's a whole bunch of different layers of complexity, right? So the first one is partition mapping. You need to, and there's two approaches, right? There's the algorithmic approach that says the input is the customer ID and the output is, shard 1, shard 2, whatever. Or you have this database, this simple database that says customer 1 is on shard 1, customer 3 is on shard 2, et cetera, et cetera. So you need to introduce this layer here, or this concept that you can predictably, deterministically say that all the data for this customer is on this shard, right? And then forward your request to that particular shard. So that's one thing that you need to introduce. You also need to introduce another layer, which is the routing layer, right? So instead of directly interacting with your database now, you need to interact with your routing layer, which will interact with your database on your behalf. So this is something that you need to build, because this doesn't really come for free in at least any of the solutions that I'm aware of. So that's another big problem with this. The third problem is a little bit of a tricky one to handle, and it essentially has to do with non-uniformity of your data, right? So, and what I mean by this is, if you know hashing functions, the goal of a hashing function is to split your data evenly. So if you have 100 rows or 100 pieces of data and 2 shards, you want 50 and 50, right? You want half your data on one, half your data on another. Now, depending on the way your application works, in this example, we were talking about customers. What if we have one customer, let's call them a heavy hitter. They are a very, very large customer. They have tons and tons and tons of data on your application. What can eventually happen is that your shard size can grow far apart from one another. So depending on the key that you're using, in this case it's customer ID, if you run into a scenario where you have this uneven storage of your resources, the size of your shards can be very disproportionate to one another. And in order to handle things like this, you need to move on to the next con, which is reshuffling or resharding your data. And that kind of leads into, actually, let me just extend this one. It creates a necessity for resharding, right? For resharding. And this isn't something simple to do. Now we have like different databases that are holding all this information. We have another database that is storing the location of where your customers are located. So you need to kind of orchestrate this workflow to change that one master database that's storing the location of all your customer IDs and which database they're all located on, or which shard they're all located on, and then actually separate out that database into a different shard. So there's more complexity that comes with this, right? Because now you need to build this process into your application so you can handle it elegantly. So that's one thing that you need to be aware of, and that kind of happens as a result of non-uniformity of your data. And the last one that I want to touch on is it kind of going with this approach kind of restricts some of the queries that you can do. Not necessarily restricts, but makes them a little bit more complicated. And this is especially in terms of like analytical type queries. So if you imagine a world where you have a single database and you want to say, give me all the customers or give me all the accounts where account balance is greater than 500. That's trivial, right? Select star from accounts where balance is greater than 500. Done, right? No more thinking. With this approach, with the sharding approach, you have all these different databases now, right? Or all these different shards that have databases underneath them. So you need to have your layer know to go out and collect all the information from the different underlying databases, wrap all that up, then return it to your caller. So it's not very well suited for analytical style queries because it introduces the necessity to go out to each individual shard, grab all that data, and then return it back to your customer. So as opposed to one big bulky query, if this were all on one database, you have smaller, more numerous queries that each individually may get a small amount of data, but your routing layer needs to be aware of kind of where this information is located and also have logic in it to A, perform the queries, and B, summarize the queries, and C, aggregate that information and send it back to the caller. So this is one of the problems with this. So you need to kind of be aware of this. So this is kind of what sharding is and my introduction to database sharding, at least horizontal sharding. I have another great video on this topic, kind of parallel to this on horizontal versus vertical scalability. I highly suggest you check that out. If you have any comments or questions, leave them down below. And as always, if you like this video, don't forget to like and subscribe, and I'll see you next time.